Hi, I'm Elizabeth McCulloch, and I am part of Project Vive, which is bringing assistive communication to children and adults with communicative disabilities. The idea came from an exchange year that I spent in Ecuador, where I worked in an orphanage with 15 kids with nonverbal cerebral palsy.
One of the girls I met was Christina, who was kind and had a great sense of humor, but through nonverbal cerebral palsy was unable to communicate with me through words. She could never introduce an idea or feeling without me or a caregiver guessing it for her.
I started researching ways to help these kids effectively communicate, and what I found were devices that were offered at a high cost and high maintenance, making them completely inaccessible to people like Christina. The only way that we could communicate would be by me asking her questions and her showing either a positive response with her facial expressions or a negative response. But all of these kids, including Christina, could all move a joint. If it wasn't a finger, then it was a toe. If it wasn't a toe, it was a knee. And I thought to myself, what if I could use these movements to sense them and use them to construct sentences to help them communicate? So this is Project Vive, and let me show you how it works.
We have created sensors that are customizable to the user's specific movements. This includes pressing of a finger, flexing of a finger, wrist movement, elbow movement, knee movement, pressing of a toe, and more. The movements are used to make selections from menus the user hears through an earbud, allowing them to construct full sentences. In this example, the user simply presses his finger to make selections. When they've created their phrase, they can say it through the Vive device to whomever they're speaking to.
Many assistive speech devices today use eye tracking, a tool that follows a user's gaze to select what he or she wants to communicate from a computer screen. While eye tracking can be effective and innovative, it can appear impersonal and has costs that make it inaccessible to many individuals. Placing a screen between two people prevents face-to-face interactions. Nonverbal communication, including facial expressions and gestures, is thought to be more than 80% of human communication. But what if we took away that screen, allowing the user to interact face-to-face with the person they are speaking to? No longer would they be burdened by large screens, but could communicate through the Vive device. A device that can be as small as a watch or fit inside your shoe, something that no one sees.
We are making a device you can drop, something you can use without access to electricity. We're taking away screens and noticeable electronics and replacing them with a device the size of a bracelet. We are building something that can easily be fixed. We are creating a technology that can be accessed by the unreached. We are giving and never taking away the freedom that comes through speech. We are building Project Vive.